Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this specific video, you will see that we are discussing about interview questions with respect to hashing data structure. Now, for those people who are not aware about this specific data structure, specifically in Python, it's called as dictionary, where there is a mapping of key value pairs, where key is something which is a unique entity, and corresponding to every key, we will be having a value, which can be a single entity, which can be any other data structure as well. For example, if you have observed in our real time, illustrations, wherever we want to store any database, any data. For example, let's say I just want to store the record of the employees working in my company. So for every employee, I will be having a unique employee ID that will become the key for my dictionary, and that specific employee ID mapped towards the employee details, where I will be having the first name, last name, the position, the department, the salary of that employee, whatever it belongs to. So similar to that, you can consider in every business scenario, this kind of data structure is very, very important in practical real-time illustrations. So you will observe that this is a recording of my paid course which is going on, and here I'm discussing with the learners about the real-time applications of this data structure, followed by what kind of interview questions can be asked from you in an interview. So please try to watch this video till the very end. Make sure you will document your learning on the way, because definitely you will be able to get very insightful content out of the same. And whenever you're going for an interviews, I'm pretty sure that these kind of questions will definitely be asked from you as well. So let's move ahead, and before jumping towards the main session, I just want to request to everyone, please make sure you will hit like button, share this kind of videos with each and everyone. You can tag me on LinkedIn as well. Your single like, your single comment, your single share really means a lot to me. And with this, let's get started. So let's try to start with the hashing data structure that we have covered up. She also has a trouble in terms of complexity with respect to that part. And then we will cover up one question today with respect to that thing. And with that session, we will see the questions of linked list, whatever queries you have, I will ask from them, from you all. I'll try to resolve that. And then we will cover up one question with respect to linked list also. And that's how the flow will go. I have a assignment also today, which I will give to you at the end of the today's session. You have to deliver it by end of this week. Okay. So that's how we will start and complete our today's session. Just give me 1 minute. Let me take my water bottle and then we will start. So what we have learned in hashing data structure, what you guys have learned with respect to hashing?
Starts in order of constant complexity.
Uh-huh.
If there is no collision, then it is constant complexity.
Okay. Any other thing apart from this?
Dictionary, it is just dictionary table of the.
Okay.
So basically, we have a hash table, and we have key value pairs in the same. And basically, it is an efficient way to store and insert and also to retrieve the values using a key value pair.
Correct. So basically, if I'll just give you a brief nutshell of whatever things I have delivered in the recorded session, just a idea, whatever you should know at least. I have taken in depth towards the recorded session, but I'll give you a brief recap of whatever thing is important with respect to that session. So whenever we are talking about hashing, first of all, it's again a part of a linear specific data structure. So whatever be the data structure we have learned so far, we have learned linear specific data structure only. Uh, I think this week we are starting our tree specific data structure, which is a non-linear one. That's the very first part where we are starting our journey with respect to non-linear data structure part as well. Now, in a linear data structure of hashing, the complete understanding of dictionary, is based on this hashing data structure. Okay? Dictionary means it's a key value pair. It's a key value pair. Where when we are talking about key value pair, key is something which is a unique entity. Key is something which is a unique entity, means you cannot have multiple similar keys. And value can be something which is a list, which is a single entity also, which can be a single entity also, or it can be any other external data structure also, whatever be the thing is. But value is something which is corresponding to every key. We have a separate value altogether. Now, if I'll ask you any real-time example of dictionary, can you provide me? Can you think over it? Any real-time dictionary example?
Basically, we can say that we are storing the unique ID of anything, and according to that, we are having more information about the same user.
Exactly. So in any kind of a business use case, or in any kind of a industry, you all know, right? We have a data of employees, employee records. And you all know that in the employee records, we have the employee ID. In any company, whenever you will, work with any company, they will provide you a unique ID. And that is something which you can consider, or which internally they have stored it as a key. So what will happen is, at any point of time, when I will search for that key, which is the unique EID in your case, we will be able to get the entire information of your, when I'm saying entire information, your contact details, your address, your parents' details, your education details, your past work experience history, everything you will be able to get. Similarly, we usually have a UAN number. When you work, you will observe that with respect to UAN number, you will again have your employment history, your EPF account, PPF details, everything anyone will be able to get. Your Aadhaar number, right? Everyone has a unique Aadhaar number that you can consider it as a key. And in the government database, that Aadhaar number is the key. And with respect to that Aadhaar number, that all the things we will be able to see, like the people who are working in that industry, they will be able to see your details, your information of father detail, mother detail, your education qualification, everything, whatever be the registered entities that we have, your property name, everything, registration name, everything people will be able to see, your salary. So each and everywhere, wherever you are seeing that the record data will be available, we have a unique ID. And with respect to that unique ID, we have the, you can say, values available with respect to that. And usually these values will not be a single entity. It will be a multiple entities combining all together. So that's the core idea. Again, it's a very beautiful data structure. Why is that so? Because what's the advantage of using this data structure? Any idea, anyone? What you have observed in the sessions? Why people are
So
going
that
for dictionary?
Direct access.
we can
Directly
we
access
can
the
also
Yes, go ahead, Mayank.
we can also bind multiple data together according to similar type of grouping. Basically, we can do using this.
Okay, that's true. Direct access is true. Any other answer?
in case of our like complexity wise, it's constant complexity. That is also an advantage.
Correct. So basically, if you will observe, the number one beauty about this data structure is its lookup. complexity, which is constant, big
Big.
O of 1. It's constant. That is the beauty about this data structure. Ki when we are doing a search operation, till so far, in the search operation, we have talked about two kinds of searches. Which are those?
Linear binary.
Merge.
Linear search?
Quick.
No, merge is a sorting algorithm. Linear search and binary search. And you have seen in linear search, we have a complexity of big O of n, which we have optimized to logarithmic, which is log of n. Right? Log of n. So now here you can see that in the search operation, there is no as such algorithm till so far we have achieved where the complexity is constant. But when this data structure comes into picture, it guarantees that I will provide you a, you can say, algorithm where the complexity will become constant, right? Where the complexity will become constant, which is big O of 1. So now the question is how that is feasible. That is feasible because we know we have a key and there is a hash function which is working internally. For example, let's say you have a pool of values, maybe 10, 15, 24, 37. And what is happening is, yes, we have a hash table where we have a key value pair, right? Where we have a key value pair. This is key. This is value. And inside this, we will be having one hash function. And after that, we are trying to store the values, right? We're trying to store the values. This hash function, what it is doing is, whatever value you have, by the way, we have multiple different types of hash functions. Hash function is another kind of a mathematical function. If you want, you can do a great detailed study on Wikipedia page that how many different types of hash functions we have. I don't remember whether I have covered up in detail about this, but there is a very famous hash function called as, I think that's something we have covered up, division modulo hash function, right? Which says that, let's say if you want to curate 10 number of entities, 1 to 10. So you will take a value and you will apply a modulus operator, modulus n, 10 modulus n. So you will be having key as 0, 1, 2, 3, 4, 5. Let's say it is going on till 9. So 10 will be stored as, so 10 modulus 10 is 0. So 10 will be stored here. 24, let's say, will be stored here. 15, let's say, will be stored here. And let's say you will be having the entity of 6, 7, 8, and 9. So 37, let's say, will be stored over here. So now we are saying that, when we are trying to, let's say I'm saying, what is the position of 15? I don't know. I want to search for the 15 position in this hash table. This is called as hash table. I want to see where this 15 is available. So what we will do is we will say 15 modulus 10, which will be equal to 5. So it will directly jump to the fifth location and it will say that, okay, 15 is available at fifth index. Now, this kind of operation doesn't require linear searching algorithm. This kind of operation doesn't require binary search algorithm as well. Here, directly with the help of this hash function, we will be able to compute the index value and we will be able to get the answer. This is what, if I'll ask you, in this case, to get that 15 value, that where is that available in the hash table, what is the complexity? So what will you answer? Can I say it will be big O of 1? Kyunki yahan pe we are not using any loop. If you remember from my initial sessions, I told you, complexity is nothing, but we are using some kind of a looping. Or there is a recursion going on, then we will try to curate a recursive function, recurrence relation, solve that via Master's theorem or substitution method, and we'll get that complexity. In this case, if you will be able to observe, it's just a mathematical computation of a function. That's why it's big O of 1. So coming back to what Rashika's question was, that was to let's say we want to count the frequency of an element. It's a very famous problem, by the way. Frequency of an element, let's say in an array. Okay? Let's say I will provide you one list and I'll say 24, 31, 24, 12, 15, 31, 12, 12, 31. I want to see that what is the count of, let's say, 31 or 24 or 15. So one approach could be, which is very famous, is that why not to do with the help of a dictionary? Where in the dictionary, we will take a key value pair, key colon value. By the way, dictionary will be represented by this kind of a braces like this. Now, why not we will take a key as a unique entity that we have in a given list, and value we will take a total count of that. For example, we will be having we will take this kind of a hash table where we will be having unique values. This is key, this is value. So we have 24, we have 31, we have 12, we have 15, then again we have 12 and 31, right? So 24 is having a value of 2. So value is nothing but the count of unique values, numeric values, right? 31, how many? Which is, I think, 3. 12, how many? Let's say 3. 15, how many? Let's say 1. So 3, 3, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, you can see we have 4 entities, 0, 1, 2, 3. And for every specific entity, we have a count. We have a count of that specific key part. Means 24 is appearing 2 times. 31 is appearing 3 times. 12 is appearing 3 times. 15 is appearing only single time. If I'll ask you that, let's say if user is asking that what is the count of 31, so now I can directly answer it will be equal to 3. Now the question is, what is the complexity to achieve this task? Well, I'm talking about complexity. I hope everyone knows. How much is the time complexity I'm talking about? And how much is the space complexity? Anyone, any idea? Anyone who can give me an answer?
Big O of n.
Space complexity order of n using extra data structure.
Space one is?
Order of n
Order
using
of
extra data structure.
Okay. So space wise, it is, I hope, clear to everyone that we are using external data structure apart from whatever is given to us. And that is nothing but we are using something called as a dictionary. So that is why we are calling it as big O of n. Who will explain to me that why it is time complexity as big O of n?
Ma'am, because we have a for loop and we are checking if the element exists in the dictionary or not.
Okay. And what if element is existing? For example, in our case, it is there. Then we're returning the answer as 3. So is that a constant task or what is happening internally?
First, we need to as a whole, first we need to traverse the array and we have to store the count values. For that, it can be order of n. After that, if we directly find what is the frequency,
Okay. Okay. So what is the overall complexity in both the cases? So what you are saying that, Priya, what will happen is that's true, by the way. At every point of time, first of all, it will try to check is 24 is available. If it is available, in that case, it will just increment the count of value. If it is not available, it will place inside the hash table. I hope that's what you are saying. So that we will be ready with a key value pair where value is the total count of how many values are there in the key part, and key is a unique entity that we have. After that, let's say if user is searching for 31, it will traverse and check it out. 31 is available. If yes, it will return the value. So what I'm asking is, in both the part, first of all, creation of a complete hash table of key value pair. Second thing, searching for that value and returning the answer of a count. What is the overall complexity? Is that big O of n square or big O of n?
Big O of n.
Yes, it is big O of n. So why it is that so? Because we are running two separate for loops. It's not a nested loop. One for loop basically is required to curate this hash table where we will be having a key as a unique entity and value as a count of that. Second time, we will run a for loop to search that key value. And if let's say wherever 31 is available, it will directly return the answer as 3. Right? It's a constant task. Whenever we get the key, that's what we have learned. Lookup wise, it is constant. So if let's say you get the key, it's very easy to get the value because value is available correspond to key itself, right? So that is why it is a linear time complexity task. Rashika, now ask me a question if you have in this question.
Yeah, I was asking when we are creating the dictionary, how is
Huh?
that loop working?
Okay. Shall we do a code for the same? Everyone? I think that then it will be better
Sure.
clear. Okay.
Yeah.
Let's try to. Is it a question I was covering up in the session from LeetCode?
No, I guess.
Okay. Let's
It's the
search for it.
duplicate numbers.
Duplicate numbers, is that so? वो तो LeetCode
Yes.
पे available है. Let's check on
हाँ.
LeetCode. Contains duplicate. Find the duplicate number. I think यही होगा फिर. This is a hare tortoise approach. Let's remove that. Can we do this question via hashing? Everyone, think over it. This question we have dealt previously as well, by the way. And if you remember, what we have done here is that we have applied a hare tortoise approach of Floyd cycle detection. But can we do via hash table?
Yes.
Count the frequency.
Yes. So basically, what is happening is in this specific question, they are talking about they have been provided us a list. And what they're saying is find the duplicate numbers. It's very simple. For example, we have 13422. So what they're saying is, can you give us a duplicate entity, which is 2 in our case? In this specific case, the output is 2. So what if I'll create a hash table again, where the key is 1, 3, 4, and 2. Value is 1, 1, 1. And for one number, it will be obviously repeated item, which is 2. Then I can make a constraint that at any point of time, if the value is more than 1, that will be called as a duplicate number. So I will return that. So what they're saying is there is only one repeated number and return this repeated number. That's the one approach, although I don't feel it's a optimized approach in this case because we are using an extra space and they're saying that you have to use a constant space complexity. So for now, in this session, we are not talking about efficient approach because efficient approach we already have covered up. And I hope you all know that. Can I pre-assume? You know the efficient one, right? So
And
let's try to
Yes.
work upon the hash table wala part. I'm not sure whether it will pass the entire test cases or not, but at least whatever cases are available, it's a very small cases. So it should be submitted. It should be accepted. So let's try to, can anyone please give a try, write a code. First of all, we have to create a hash table where we will be having a key value pair where key is whatever the unique entities we have, value is the count. And once you curate that, we have to apply a constraint that any value more than 1, that is a part of a duplicate number. So in that case, you're supposed to return the corresponding key because what we want is the key. For example, 2 is the key, having value 2, which is the count. So we want the key, which is 2. Can you try, everyone? Please do it. I'll wait for a few minutes and then I'll write a code. If anyone will not give me the code in that scenario. Do it step by step. Let's see who will be able to give me the answer. write a code. Shall I share the problem with everyone? Let me share in the chat window also. Although you can just search on LeetCode, find duplicate number. We already have covered up this problem. It's available in the list as well, I think. Yep, it is available. Duplicate number in an array. So just open it and try to do it. And then we will approach a second problem also today regarding the similar aspect of hashing. How will you create a hash table? Empty hash table. First of all, create that. So it's very simple. Initialize it. Maybe you can say count underscore dict to store the count value in a dictionary. So that's a simple initialization which you can do. Now what we have to do, we need to run a simple for loop for num in nums. So it will take one by one number. And what we have to do, we have to check that is that number is already available in the dictionary. So if that num is in count underscore dict, if it is available, what we're supposed to do? Any idea, anyone?
We have to append basically.
We need to not say append.
Sorry.
We need increment the value.
Increments by one.
Increment the value. Can I say everyone? So how can you increment the value? So in dictionary, we can get the value just by writing count dict bracket key, which is num. Always remember, it's kind of a way to access the value. One way to understand this concept is, for example, I usually say this thing to the learners that, for example, what usually happens when we talk about list data structure, we have a default indexing. कि अगर हमने कभी list array बनाया, so we know that we have a default indexing कि let's say 22, 43, 37, 56. So in that scenario, we have a default indexing कि 0 पे हमेशा 22 होगा, 1 पे 43 होगा, 2 पे 37 होगा, 3 पे 56 होगा. But when we're talking about this specific data structure called dictionary, it's kind of, we are giving a manual indexing कि 24 index पे 2 value होगी. So you can think like that. You are giving your own customized indexing. So the way to access a value is same just like the way you have to access the list value, index number देके, right? तो जैसे अगर हमारा डिक्शनरी का नाम dict है and you want to access that what is available corresponding to 31, you will say dict of bracket 31. It will give you the answer as 3. तो अब हमें क्या करना है इस केस में? We want that value should be incremented by +1, right? So we will say plus is equal to 1. So what will happen? Whatever be the value available at correspond to this num value, it will increment that by +1. If that is not the case, else what we will do? अगर ऐसा नहीं है, means that number is not available for now in the dictionary, then we have to place. So how will you place? Create. So you will say just do one thing, create and pass a value as 1 क्योंकि अब तो आ गया है ना. So we will pass a default value as 1. This is the way to create a hash table in the form of a key value pair. Is that first task is clear to everyone? Then we will go to the second task of constraint. Is that fine? Just listen this very carefully. I will give you second problem which you have to do. I am doing it for now. I'll give you second problem. Similar approach only you have to adopt in that scenario also. So it's a pattern. So you have to understand it. Okay? Now we know that at any point of time, if the value is more than 1, it's a part of a duplicate number. So हमें वो return करना. Now how can we find a duplicates? That's the second question. Right? Duplicates कैसे मिलेंगे? So any idea?
Not equal to 1. It is a duplicate.
Okay. There is a function in dictionary called as items. Do you know? How many of you know?
Yes,
So what will happen if I'll just say count underscore dict dot items? Who will tell me?
Yeah, it
So
will
we
give
will
both keys and values.
keys
It
and
will?
values.
Okay, okay. So see now this thing very carefully what I'm doing. This is what is coming currently in my head. I am using a list comprehension again. Num4, let's say I'm just saying I have a number and I have a count value, right? Which is a value. In count underscore dict dot items. Items. If count is bigger than 1, what is happening? Anyone who can just let me know this kind of constraint, what it is doing?
You are iterating over all the key value pairs and you're writing the if condition, verifying if the value is what are the values greater than one. You just return the key value with respect to the.
Am I returning key and value
So
both?
by using the items, we are getting the key and value both. The num is the key and the count is a value of the same basically.
Okay. So here we are
And
running a
then
loop in the hash table where I have a key, I have a value. Key name is number and value name is count. That is fine. Now tell me the second step, what it will do. Second step.
so it will check if the value is greater than 1 or not.
Then what will happen
And
if it is true?
so if we have to return the same, the num.
So it is storing that num value in the duplicates variable. Can I say everyone? If the
Yes.
condition is true, it is storing that num, which is a key, because that is what we have to return. And we are storing that in the duplicates. So it's a kind of a list which is forming up. And if I'll just return this duplicates, let's see whether it will run or not. What do you think? It is running fine? It will run fine or it will throw some error? Is the logic is correct? Syntax, so we will see if there will be an error. But logic should be correct. Let's try to run this. There is a runtime error. Plus equal to में आ रहा है, I think. Plus equal to should run usually in Python.
In my case, it's I guess something else is done.
Let's see. कुछ हो रहा है क्या?
Can we do that if count is not equal to 1?
If count is not equal to 1. एक मिनट, error क्या है?
Is it
I guess
because we're
we don't have
returning a
to
list
a
and we
list.
have to return an integer?
I think
Integer.
that is the issue.
So we can
That
do
is
is
the issue.
duplicates 0. We can iterate the first element of the duplicates added in return.
Let's see. Let's see. I think this should not be an issue. Let's see. That is the issue. But actually, we are returning the list and they're expecting us to return a single answer. Anyhow, the kind of question which they have given, they have said there will be only one repeated number itself. So it means that in duplicates, you just have one number itself in a list. But anyhow, it's a list only, right? So let's try to see in the submission part. It is submitted as well. Oh, I thought it will not get submitted because they have specifically mentioned, but some questions they usually pass. It's okay. But they have clearly mentioned that you have to write an approach of constant extra space. So definitely, if you will say this approach to the interviewer, they will ask you a more optimized version, which we have already discussed, right? Now let's talk about the complexity part. So that's what I was talking about. In this case, you can see, right? We are applying one for loop to curate a dictionary, or you can say hash table, where the key is num and the value is the count. So that is why in this specific first part, if I'll ask you the time complexity, it is big O of n. Big O of n to required to create a hash table. This is the first step, big O of n. Second step, where again I'm applying a for loop. You can see, right? To get that number where the count value is more than 1. So in this case, again, single for loop is running on. That's why we are having a complexity of big O of n. To get the key having count value more than 1. In this specific case, it's not a nested loop. When I'm saying nested loop, it's not that there is one loop, outer loop, and inside that I'm applying an inner loop. One loop is there, then second loop is there. That is why complexity is overall big O of n plus big O of n. So overall, you will observe it is time complexity as big O of n to create the hash table, big O of n to get that element which is having a count value more than 1. Overall, it is big O of n. If I'll talk about the space complexity, in the space complexity part, it's the extra space which is required. And because we're trying to create a hash table, it's again linear. So that is something which you have to understand. Now tell me the answer. Any doubt, Rashika?
No, it's clear.
It's clear now how we are
Yes.
accessing the element. First of all, how we are doing a creation and why it is not big O of n square. Makes sense now?
Yeah, makes sense.
ठीक है. Yes.
I have some small.
Yeah,
The
please
num
answer.
duplicates equal to nums for nums comma count in counting. So it is actually doing like it is traversing the key value pair dictionary and also checking the if the count is greater than 1, isn't it?
Correct.
After that, the return duplicate 0. It means for those key value pairs which is count is greater than 1, it is traversing and returning that.
So can you see
This
the
the return set.
Mayank's code? अच्छा तुमने host and panelist पे किया. I'm sharing the code of Mayank. He has shared personally to me, but I'm sharing to everyone. So can you see the below line, last 3 lines which he has written? For num comma count in nums underscore count dot items. If count is not equal to 1, return num. This 3 lines of code, I have done it in a 1 line. That's the, I would say, main idea. So one way could be that you will write a step-by-step loop. For example, you will say, let me just split the same code into multiple parts. So you're applying one for loop. Okay? Inside that, you are saying that at any point of time, if my count is not equal to 1, that's what he has done, you're directly returning that number. What I am doing is I'm not directly returning it. I'm saying store all those numbers in the list, which I name it as a duplicates. And then I'm returning the first 0th value of that. So either you can do like this or you can do like this. It's one and the same thing. So now I hope
Basically,
Mayur it is clear.
in
Sorry,
MAM's approach,
please
we
explain
can
again.
get multiple
Yes,
duplicates.
correct.
Sorry,
So
please
in his approach, what is happening is you will get the very first duplicate entity and it will running perfectly fine. In what I have done is I have said that, let's say interviewer has changed the question and he's saying that there can be more duplicates. In this case, in this question, both the approaches are fine. Either you can do like this or you can do like this. But if let's say interview change the question, he will say, give me a list of all the duplicate elements. It is also one of the very wide last question कि हम आपको list दे रहे हैं, आपको सभी के सभी duplicates बताने हैं. In the list, mention all those keys which contains duplicacy. So this approach is the apt approach because in this approach which Mayank has mentioned, only first duplicate number will come up. But what I'm doing here, I'm trying to store all the duplicate elements in the duplicates list. So I'm creating a list here. That is why when I was running initially directly duplicates, it was not running. It was giving me runtime error because the kind of format which they want from me is integer. What I was returning is a list. So what I have done, I have just done a first element, return that. So now it is coming up fine. So that's the main idea. But internal logic, which you are seeing in these 2 lines, is same, which I'm getting over here. Is it fine, Mayur?
So, ma'am, I have one
Mayur?
more logic that I
Yeah.
have got right now. So the
Yeah.
logic is only applicable for only one element, and it is like that. For example, we have a list, and first of all, I will sum the list using the sum function, and
Okay.
then after then I will convert the list into a set. So
Okay.
the duplicate element will be removed, and then again I will
Yeah.
sum the set and then subtract both of them.
Correct.
So what would be
That
the
is
time
also one of the approach.
complexity?
So again, here you are using various data structures, right? List is already given, but you will create a set, right? And it will take 1, 3, 4, and 2, because we'll just have single element. You are saying that you will do the summation of num, you will do the summation of the set that you're getting, making a difference, you will get the missing value. That's a correct approach. So it's kind of, in a set you are doing a curation, so it will be again of big O of n as the space one, but in the time part it will be again big O of n only. So it's kind of similar what we are getting over in this specific approach as well. Okay.
Okay.
But the most optimized one, see, whenever these kind of questions can be asked from an interview, always try to give these kind of approaches in the very first go. We will use set as a data structure, we will use hash table as a data structure, talk about the time and the space. And after that, when that person will call that, okay, this is fine, we're getting a correct approach, it's a correct answer, we're getting a test case running part, but can we optimize it further? Then you can extend and you can talk about that Floyd cycle detection algorithm, where the constant space is there and linear time complexity is there, and you will be able to easily answer to them. Okay. So that's the kind of a flow which you should always retain. I always say, in an interview, it all depends on you. Try to see, usually interview happen for 45 minutes in any company. And the main idea is that if you will be able to answer 2 questions properly of DSA, you will be passed out to the second round. So make sure if you will answer directly the correct approach, the time requirement of giving that question commitment is less. So they will ask you 3 questions or 4 questions. So don't go with the maximum questions. Try to dedicate more time in a single question, but by saying that, don't dedicate 45 minutes in one question itself. Like 20 minutes is optimal time. You can, for the first 5 minutes, talk about brute force approach. In the next 5 minutes, you can talk about intermediate and advanced approach. After that, you can, in the next 5 minutes, try to write a code. In the next 5 minutes, try to talk about the time and the space complexity. So that's how the flow should go. And that would be a better idea to answer the questions in an interview, right? Shall we proceed to the next question then, if it is fine for everyone?
One more doubt basically.
Yes.
For the hash function, we are using modulo stuff,
Yes.
basically mathematics stuff. What if the
Yes.
key is not an integer, it is a string? What would be the complexity of the same? Uh,
So, yeah,
are we using a Saki code for the same? And the
correct.
second question is that for the same, what if the value is not an integer, it is a string? So it's same.
Same thing. So for all the, I would say, character-based data, we have a SKI code available. So internally, what will happen? They will directly point into the SKI code, doing the summation of all of those character values as per the SKI mapping. And even the SKI mapping internally is in the form of a dictionary specific data structure. So wherever you will observe that there is a mapping of something with respect to everything. So, for example, for every character, we have a numeric number. So it's a dictionary, right? So they will do the summation, then hash function will be applicable over there. That's how the thing will go. Same thing will happen for the values as well. So whenever we're working with any string or character-based data, our code usually don't understand that. So by default, the idea is to convert into a numeric one and then work upon that. So in the DSA part per se, SKI code plays a very important role. In data science per se, word embedding techniques plays a very important role. So there is always a technique for which we will be converting our textual data into a numeric one. Several techniques are there, but for your question, in this specific aspect, it's SKI code part. Okay.
The last doubt about this question.
Yes,
Please,
Mayur.
please explain the set. So, like the set, the way of solving using set. Please explain. Yeah.
How can we solve the same question
Using
using set?
set.
That's what you are saying.
Yes, that like you have discussed, but I have not discussed that.
So what we can do, what Mayank's approach was, he, said this approach, that is that correct or not? So we have nums available, right? 1, 3, 4, 2, 2. Now, what is the difference between hash table and set? Or I would say dictionary versus set. This is also another question which can be asked from you. Actually, they both are same data structures, personally speaking. But in the set, default configuration is key will always start from 0. Okay. Now, in this specific case of set, I hope you all remember that there will be no duplicate elements. So as soon as you will try to convert your data structure of list to a set, it will remove all the duplicate entries, right? In our question, they are saying that there will be only one duplicate entry will be there. That's the thing which they already have mentioned. We have nums table available, right? So as soon as you will convert this nums list to a set, you will get the answer as 1, 3, 4, and 2, because it will simply remove the duplicates. It will simply remove the duplicates, and that is why we will be able to get the answer as 1, 3, 4, 2. Now what will happen is, if we'll do the summation of 1 plus 3 plus 4 plus 2 plus 2, we will get the answer as 3 plus 4, 4 plus 4, 8, 8 plus 2, 10, 10 plus 2, 12. When we'll do the summation of this, what is the answer? 4, 7, 8, 10. And when you find the difference between the original data that you have, 12, minus set data, it will give you the missing, or not missing, I should say, duplicate value. So that is what he was saying, and that is the correct approach. This will also give you a correct result. I feel so. Is it fine?
But it is not optimized.
So like if the question is that we have to return multiple duplicate values, then we
Then
have
it will
to
not
use,
work.
yes, then we have to use your approach, no?
Correct,
the way you,
correct. This approach will work in this specific question only, where they are specifically saying we just have one repeated number. If you have multiple repeated numbers, in that case, definitely you will get the summation of that. So that's a different scenario altogether. Rahul, why didn't we use dictionary to store key value pair in this code? In the set, see, key value pair will come only in hash table or dictionary part per se. Set is a different data structure. Dictionary is a different one. List is a different one. Linked list is a different one. All of them has different ways to store the data. When you're talking about key and value pair, in that specific scenario, you will always have to go for dictionary or mapping or hashing. That is where we have discussed this approach, which I have just now implemented. What he has said that can we do the same thing with the set? So that is the answer which I was responding to you. No, I cannot hear you. Where is, yeah, please tell. I have given you the permission now. Unmute yourself. Yes, now you can speak.
I'm not asking a question about the code that you're showing. I have pasted a code in the chat that is with the starting class of hash table.
Okay, let me check. I have not checked that. There are multiple things coming up in the chat window. Let me just copy this and let me check. Oh, got it. This is the problem. I think this is what in the recorded session we have done. So what he's asking is, let me just copy over here first of all. So he's saying that why didn't we use dictionary to store key value pair? Anyone who wants to answer this question? Anyone who wants to answer this question?
I guess we are doing the implementation of dictionary behind us.
Correct. See, this is again a very confusing point. Many people in the batch usually gets confused. It's a good question. I think this will resolve multiple people doubts, even the people who will watch the recorded videos as well. Whenever we are talking about data structures, right? We have talked about list, or I would say arrays. We have talked about linked list. Now, when we are talking about stack, when we are talking about queue, when we are talking about dictionary, when we are talking about, let's say, tree, when we are talking about heap, all of these are different data structures we have apart from arrays and linked list. But the base of curating these data structures is array and linked list only. When you are talking about dictionary, this dictionary is having a format of key value pair. But how this key value pair will be created and how this works internally, that's what I was talking about. So what you will observe that internally, when you see the documentation, when you directly call this function of add item or get item, internally we are using array only to store these data values. But the way we are storing these values in the form of a key value pair, that's why we are calling it as a dictionary. Same thing will happen for trees also. You will observe that we are internally using either an array or a linked list depending upon what kind of tree we are working with. Same thing will happen for heap also. It's just that the structure is changing. That's why the naming is changing. But internal base is same only. Either we're going for arrays or linked list. Does that answers your question?
So you mean to say whenever we add a key value pair to the dictionary, internal logic is the one that you have showed us?
Correct. Correct.
Okay.
What is the behind the scene when we are trying to curate a hash table? So when we are saying hash table of key value pair, it's nothing but is a array only. That is what I have showcased you internally. But on the top side, when we directly access the values, we just see that, okay, there is a separate data structure called as hash table or hashing where key value is true. But how internal thing is happening, how this is storing the values, I have showcased you that part. Okay? Same thing you will observe in stack, in queue, in heap, in trees, everywhere. Common. Okay, perfect. Any other question? Shall we move to the next question?
One small thing.
Yes, Mayur?
Here, as you mentioned, that internally this array. So just I'm guessing, I might be wrong, that between array that we can via we all the elements we have indexes are there. So is that how somehow it is connecting with dictionary key value, array index value, or I am wrong?
Can you repeat your question? Your voice in between gets lost.
Like
Please repeat.
you, if my voice is clear now.
Yes, it's clear. Please go ahead.
Yeah. So as you mentioned that here internally this array. So like okay, dictionary is there, key value pair is there. Internally it is array. So in array we have all the elements we have indexes. So is that kind of thing that in dictionary key value pair array we have every element we have index? Can you please explain? Or
correct.
What I'm thinking it is correct.
This is correct. For every list we have, by default, you will observe key value pair in any list where key is the index number. That's what a few minutes back I told you. It's just that now we want a customization of that, if you will see the structure very appropriately. So what we are doing in this hash table or hashing specific data structure, we are saying that I don't want a default configuration. I don't want key, it will always start from 0 and whatever the first element I have, it will be placed in a 0 indexing part. That is where if you want a separate key to index to access any of the value, that is where this specific data structure comes into picture. And that is why we're using arrays here. Because random access is possible. That's what we want. We know in an array, random access is a linear time complexity task. Sorry, constant time complexity task. And that is where to apply the same approach, because we want a constant lookup value also. Researchers have thought at that moment that why not to customize this array itself in a way that we will be having a key value pair where key is somehow the unique entity or the number and value is a value corresponding to that. And anyone who wants to access, because we know in arrays random access is possible with the constant time complexity, so it will be able to directly access the element. That's the thought process behind this part, this creation of data structure. Is that fine, Mayur?
Sure.
Okay, perfect. So let's move ahead now. I hope all the questions have been answered very clearly. Now I'm giving you one more question. And this question we have already discussed, but it's not the same question we have discussed. So in a sheet, if you see, in one of the session, live session 2, we have discussed about two-sum problem, where the input array is sorted. Today, I am discussing another two-sum problem where the input array is not sorted. So the problem looks like this. Let me share this problem with everyone. Again, a very famous problem. And you must have seen this problem a lot in the interviews as well. What they are saying is, in this specific case, so do you remember how we solved this problem where input array is already sorted, target value is available, and input array was sorted?
Some two-pointer to
Two-pointer approach was there, right? To get that optimized result. Two-pointer approach was feasible only if we will be having a sorted array. In that session also, I told you. But in this case, the array is not sorted. So the question is, how can we solve this problem? Let me completely finish this part. Okay. So the question is, how can we solve this problem? So we have a number that nums array will be of any of the order. A target is available. Problem statement is same only, that you have to find a paired indexes where combining both of those values will give us a target value. For example, 2 plus 7 is equal to 9. So what we want to return the answer as 0, 1. So the question is, how can we approach towards this problem? Any thought processes, any answers can I get from anyone? Please go ahead. One thing I forgot to do, I will just copy that code of duplicate numbers, which we have done today, so that I can share with everyone after the class in the notes part.
Ma'am, what is the minimum time of complexity in this question, the optimized approach?
Big O of n. Big O of
Basically,
n.
we can run a for loop and we can store the sum into a key value pairing index type. Is it approach?
Sorry, how will you apply a sum operation over here? That's the question.
I guess the previous element of the array index and the next element of the array index. Index plus 1, index minus 1, like to store the sum.
So what is the
And
complexity for that?
I guess big O of n.
No, that won't be big O of n. Let me just showcase you what you are saying, and then you will tell me. Just let me do one thing before that. Let me just save the previous code. It was finding duplicate elements. Meanwhile, you guys keep on thinking what we can do. Okay, let's discuss this part. Let me take this end to end.
I guess it wouldn't be big O of n.
Yes, it won't be. See, one idea could be here we will be having nums array, right? So we have 2, we have 7, we have 11, we have 15. So now, what I can do here is 0, 1, 2, 3. One idea could be where you can say that, Priya, I will try to fix one element and just keep on checking the addition of other elements. And I'll just keep on check that whether the addition will come out to be a target value or not. For example, I have currently 2. So 2 plus 7 is 9. So it's a best case scenario where we will be able to achieve this thing. But worst case could be that I'll fix 2 and then I'll just keep on adding 7, 11, 15. Then I'll fix up 7. I'll check for 11 and 15. I'll fix up 11. I'll check for 15 and so on. So I will check all the possible edge cases by fixing one element and exploring the other pending elements that we have. So in this specific scenario, if I'll ask you the complexity, so what will be your answer? It will be
Big O of n.
big O of n square, not n. Again, listen the problem statement very carefully. You are
Okay,
fixing the value, and inside that, you are exploring all the possible cases. So isn't it I value will be 0, j value will be 1, 2, 3, I value will be 1, j value 2, 2 and 3, I value 2, j value 3, and that's the idea. So it will be big O of n square, and this is the brute force approach. Is that clear to everyone? Or anyone who is not having a clarity over this part, which I'm talking about here? To get the two indexes, will that approach will work fine? What do you think, everyone?
So can we do like this one? Basically, we have the target, we are running a for loop, and we are subtracting the target from each element, and we are checking if the uh, difference is in the array or not.
Very good. That
That
is
can
where
be
the
work fine.
optimized approach comes into picture. That's a correct approach. So now this is the brute force approach, which is a quadratic, or I would say n square time complexity that we have. So how can we optimize it? Just like the way Mayank said, why not we take the difference of the target and the current value and store it in a hash table? So again, what I will do, I'll just try to copy this value. I will be having an array which contains numbers like 2, 7, 11, 15. Zero, 1, 2, 3. Target is 9. Now here, one thing which you will observe, what will happen is, let's say initially my value of element is 2. So what I will do is, I will try to take one hash table. Again, this hash table will contain a key value pair. The very first thing which I will do is, this is a key, this is a value. That I'll try to find the complement. Complement means whatever with the current value I am getting, I'll take a difference between target and the current value. So initially my value is 2. So 9 minus 2 is 6. Sorry, 7. So complement, I will be able to get a 7. So I will check, is that complement, which is 7, is available in my already defined hash table. If it is available, I will directly return the answer. If it is not available, I will make it available. So it is not available. So what I will do, I will make a key as that number 7. Sorry. I will make the number, which is 2, and the value as 0. So value is my index number. And key is my actual number, which I'm working with. Is that fine? Because that complement is not available, I'll just directly store the data inside my hash table, which is a key value pair, where key is the number and value is the index value. Because at the end of the day, we want to return the indexes where that pair is available. Shall we move to the next iteration? I value 0 is done. I value 1, 7. Now, 9 minus 7 is 2. Complement is 2. I will check. Is the 2 is available in my hash table? Yes, it is available. If it is available, what I'll do? I'll return what is the complement index value I will be having and what is the current index I will be having. So current index value of I is 1. And what is the complement index value? It is 0. So 0, 1 will be returned. Think over it very carefully. Again, I am repeating. What we are doing is, we are trying to find a complement. Complement is the difference between target minus the current number which we have. So initially it is 2. 9 minus 2 is 7. We will check, is it available in the hash table? If it is not available, we are storing the current value, which is 2, and its index number. We'll move ahead. I value 1. Again, we'll try to fetch the complement. 9 minus 7, 2. Is it available in the hash table? Because you know, right? For example, if you're saying that num1 plus num2 combined together will be equal to target. So obviously, if you have a num1 available, num2 definitely will be equal to target minus num1. It's a simple maths. So we are using this simple maths to get that idea. In the hash table, is that target of num2, target minus num1, which is num2, is available or not? If it is available, I know the index number of that. So what I'll do, I'll just get the complement index number. I'll just get the current index number. I'll return that. That's simple. And we're done. So that's the whole idea, with the help of which we will be able to solve this particular problem with the help of a hashing or hash table data structure. Why I'm covering up this question today? Because I want to again showcase you another question with respect to how this hash table is beneficial in terms of storing the result. Now, in terms of time complexity, if you will be able to observe, it will be linear because in one time we are exploring the thing. In terms of space also, it will be linear because we are using a extra space to store the result. So for the time and the space complexity, it will be a linear task. See this very
I guess
carefully.
we can use without a space.
That's an optimization that we can do on top of that. But for now, because we want to see the implementation of hashing specific data structure, so that's the main reason we are covering up with this approach. Then we can see how we can do apart from this. That's a separate discussion altogether. But is that discussion is clear? Can we do the implementation for this?
First, actually, we have to create the hash table, isn't it? We have to store everything. After that, we can check for the target and whatever it is subtraction is there, or directly we can check the
No,
subtraction.
directly. So we will try to take a empty hash table. Maybe again, you can take a hash table of maybe count underscore dict, or you can say, because you're storing a number and an index, you can take a hash table of num to index, which is an empty one, and directly you can start your journey of iteration, and whenever you can't see, you can just try to store that number and the index value, and if there is already availability, then you can directly return the answer. Simple. There is no need to first of all store the values 20, 71, 11, 2, 15, 3, and then do this task. Does that make sense?
Just the empty hash table.
Yes, correct.
No. Like, can you please explain the empty hash table and after the next stuff? That's just a little bit confused.
So what we are doing, for example, we initially have an empty hash table. There is nothing available over here, right? It's empty. So we are starting our journey. We are applying one for loop. That for loop will again take the, you can say, index number and the actual number in the main table that we have. So we will use enumerate function and nums value. So what will happen in enumerate? It will give you the index number, which is 0, number is 2. So what will happen is we will try to find out the very first step, complement value, which is the difference between target, which is 9, target minus number. So for now, my complement value will become target is 9 minus 2, which is 7. I will check, is that complement value is available in my number underscore 2 underscore index. Is my target value is available? Is my complementary value is available? If let's say it is available, in that scenario, I'll directly return the answer. If it is not available, in that case, I will directly try to store the value of this dictionary, whatever be the nums to index dictionary that I have. I'll store that number, and corresponding to that number, the value is the index number. Why I'm storing the index values? Because I want to return that. That's the main idea. So what will happen is 7 is not available in this dictionary. So it will do one thing. It will store the num and the index value of that, which is 0. It will move ahead. I value will become 1 now. At I equal to 1, again, it will calculate the complementary value. 9 minus 7 is 2. So now my complement is 2. It will check, is it available? Oh, yes, it is available. So in that case, it will return what is the value available at this complement of key, which is 0. And what is the current index value? 1. It means that 0 location is 2, 1 location is 7. And the addition of both of them combining together will become 9, which is true, which is equal to target value, which is true. Is it fine? Shall you guys, try to approach this problem in the window, LeetCode window? Please implement the same solution. Do it step by step, whatever approach we have discussed, and then maybe we can discuss further. Mayank, I don't think this approach should work because of one reason.
Basically, I have implemented the above code in Google Colab right now, and I guess it is working. That's why I have sent this.
Just try to implement it in the LeetCode platform. In terms of returning, logic is fine. But in terms of returning, I feel you should face the trouble. Let's see. Meanwhile, please everyone try to implement whatever logic we have covered up. Because the thing is, we want to return the answer all in the form of a list. And you're returning it step by step. That's the idea. Logic is fine.
I guess in the last I have to append all the values to the first.
That is what now. In that case, again, space complexity is being used.
Yes.
So it's one and the same thing in terms of complexity wise, right?
But I guess we are not using dictionary. It is English.
Yeah. Yep. First of all, can everyone do this part? Then we will think whether it is even feasible to approach this question without space complexity or not. That's a separate discussion we will do after this part will get over. Don't worry. Or maybe I'll give you a task, I'm not sure. I got one solution from Mayur, but again,
There is one more solution below the signal.
I think it should work, what he has done. Let me try to copy his code, Mayur's code. So he has created a dictionary first. That's completely fine. Then there will be a for loop, then getting a difference value or a complement value. If difference is available in num underscore dict, we are returning that value and I value. Otherwise, we are placing that element equal to that I value. Let's try to run this and submit this. Right? Working perfectly fine. So that is the approach which I was talking about. And I think he has efficiently handled it. So basically now you can see, right? We have created a dictionary. So we have created a dictionary here. And here we are trying to find out the complement of a given target and num value.
I have a
After
question.
that, we're getting the difference available. Yeah, please ask who is the one. Yes, Rahul.
So
Rahul.
I understood the logic for this one. So my question is like when I saw this question in my mind, I was having the thought of like utilizing the two for loop that you actually said it. But when you want to optimize this code and the way you have suggested to do is like difference is equal to target minus num. So when we are trying to when we need to come up with this kind of logic, how will actually we'll get these thoughts if we want to uh, uh, I have actually I have a problem of like my current issue is I can my brain will be working with brute force logic. I can come up with any brute force logic and I'll be able to work with that. But when I'm coming when I need to come up with some good approach, my mind will be like it won't be working. So I'm having this difficulty of converting my brute force logic to an optimized solution. So with respect to this, so um, I I never got the thought of like if we able to difference the target minus name and if we store it in like a dictionary, we would be able to optimize it. So I never got this kind of thought also.
But
So
if I will
how?
give you a similar problem of threesome now, which I think I have given in the sheet as well. Will you be able to give a thought? Maybe I can do something like this, which we have done today.
Yeah. So
So
you mean to
directly, directly, no one will be able to get a approach. Even when I started my learning journey of DSA, it's not that I was able to get clearly that this is how I can optimize this code. It's just that you are training your mind with the different approaches. Consider it as ki you are training one machine learning model, just like the way by feeding the data. Similarly, in our brain, we are feeding different strategies to solve a single problem. Now, that's why I'm saying that whatever approach you feel is something which is new to you and it is not coming in your head directly. It means there is a gap. It means that somehow you have not solved till your life this kind of a approach, this kind of a problem. That's why it is not coming up. In future, if let's say I will provide you similar kind of a pattern of a question, now it will come up. Ki, acha, in that session, we have solved like that. So can I apply the similar strategy over there as well? So the main idea could be what I'm trying to convey is that please try to, start remembering the patterns of questions. Ki, what is the main target of this course is not to solve thousands of problems. The main idea could be ki I want to showcase you different variety of problems. By saying variety, by saying that, the meaning is I want to showcase you the different optimal approaches of solving a single question. Now, you have to remember, you have to write in a proper manner, and you have to revise also. Many people say that it's a code part, it's a code work, there is no need of revision. Why we revise? It's a logical thing. No, it requires a revision. If you won't revise, you don't able to remember these kind of approaches and you will forget, and then you will just be in a loop of having a brute force approaches. Now, why this brute force approaches are also coming up? Maybe you are saying that, Priya, I'm easily able to cater the brute force approach. For few people, that is also not a scenario. Specifically for those who are from non-programming background, they usually say to me that, Priya, we are not even able to have a thought process of how we can get a brute force approach. So why? Because they have not worked with that specific mindset also. So it's a step-by-step level, and how you can improvise that is by solving multiple questions of same variety. For example, today we have solved two sum problem. Now it's your duty to, see the similar kind of a pattern and solve more questions on the same. Maybe three sum you can at your home you can try. Similarly, there is a problem of power of two, which we have solved in our earlier classes. Do you remember? In recursion, we have solved. Anyone who have remembered that? Via recursion, how we solved using divide and conquer strategy. Correct? So, same problem. Today I have given you power of 3. The main idea is why I have given you today this problem. I just want to check. Do you remember the pattern of that? Do you remember that how, with the help of a divide and conquer strategy, we have solved power of 2? It's exactly similar thought process. But it's just that I don't know how many of you remember. That's why I thought that let me give a same kind of a category of a question. Because the more you practice a similar variety of problem at your home, better your mind will be able to interpret in interviews as well. Ki, acha, this problem I have solved it. Not exactly same, but there is a bit of change. So that is how you will also able to cope up with the, optimal solutions. You have to just uh, keep on doing a practice of the multiple variety of questions. And once you get one approach, right, one logic, which you are not aware of, please try to write it down somewhere. Okay, this is something which I have find it new. And whenever I'll get this kind of a questions where, they are talking about getting a paired values of a target sum, I will definitely try to think over it. I don't know whether this logic or this approach will work there or not in that question, but at least I'll give a thought. That is something which I have learned new in this session. And that is how basically you will grow from this specific part. Does it make sense, Rahul?
Yeah. Thank you.
That is the only mantra. It's not that I'll say something special or give you some special tips to get that idea that from tomorrow onwards your brain will work like getting a optimal solutions altogether, because this doesn't happen to me as well. Maybe if there is anyone who has done that exceptional thing, so they can share with you. But for me, I feel what works for me is the practice. And why I'm teaching DSA, the only reason is I just want to have that touch. I will keep on practicing this because n number of times I'm teaching, n number of times I'm revising also the same concept. That's the main thing for you also. Once this course will get over, you will be having your notes, you will be having your documentation. Keep on revising in whatever way. For me, the revision is teaching you all. uh, I'm saying it to be very frankly, this part that the main motivation to teach DSA is this only. Many people usually ask, Priya, do you love DSA? Do you like it? Why you teach DSA? On like there is a challenging thing, there is a interesting fun solving the problems logically. I personally like that as well, but the motivation is not that one, because in life we like so many things, but we don't do that. Motivation is, I know, if I'll just left the touch, that's what happened in the industry people, right? If I'll connect with them, there are many friends of mine who usually say that, Priya, now we're working in an XYZ company, and it's been 4 years, 5 years, we have not opened the LeetCode platform, and now we have lost the touch. And now when we're going to the interviews, we don't know how can we tackle those interviews, because interviews are asking DSA round in the very first part. They're not asking that what you have done in the last 5 years. So that is the main reason. That's something which I don't want in my life also personally, and that's where when I started my teaching journey, I started with DSA only. So same thing I'll suggest to everyone over here as well, that on the very first day, you will not get a optimal approach. You will struggle. You will maybe get demotivated that, okay, I'm getting a brute force, but I'm not getting a optimized approach. But believe me, if you will sustain, keep on doing the questions, document it properly, revise it properly, after this batch will get over, I'll definitely in the last class ask the same question to everyone. You guys only will tell me that, Priya, now we'll be in a situation where we have that mindset that how can we tackle those problems, because at the end of the course you will be in a situation to solve multiple problems on your own. This answer I can expect only from those people who will solve these problems, not from those who just attended my live sessions and then they're expecting that some magic will happen, because in real world nothing is magical here. It's an illusion which you have, but the only thing is hard work and a smart work. Smart work is not solving a same type of a problem, solve a variety of problems. Hard work is you have to solve it. That's the main idea. I hope it makes sense, right? Now, coming back to the same question, is it fine for everyone? If I'll talk about the time and the space complexity of this approach, what will be your answer? What is the time complexity?
Both are order of n.
Yes, it will be big O of n, because again, you can see there is only one for loop we are running into. Inside that, we're doing everything, finding a difference value, checking that whether this difference value is available in the dictionary or not. And accordingly, either we're returning or mapping it with the for the new part of table, hash table. What is the space complexity? What is the space complexity? It will be again big O of n. Now, do you have any thoughts over the solution which you can curate without using space complexity?
No, it is not possible because we can't return the return only accept only one value.
Correct. So always remember when they are saying that you need to return a data structure, chances are very low that you will be able to get a constant space complexity. In exceptional cases, it is feasible. What are those exceptions? For example, if let's say they are saying, we will provide you a list. In that list, just maybe return only those values whose target is equal to 9. So in that case, maybe you are saying that, Priya, in the same dictionary, same list, I am doing some stuff and removing the elements which doesn't belong to that and returning the nums list, remaining pending elements that we have. Feasible. But in this specific question, they are not seeing the element value. What they're focusing is in the index values. That's why it's not feasible. So you can think at your home also, if you find some approach which you feel can give you a result, you can just let me know. But as per my knowledge per se, whatever is my thought process currently going on with respect to this question, I don't think that we will be having any approach in which the space complexity will be constant. But if you will be able to figure it out, you can let me know. You can do your research. See, there are multiple times what happened is, uh, because whenever I'm solving LeetCode questions, my habit is maximum times I want to solve it live in the recorded sessions. Few times I usually solve it prior also. It's not that every time this will happen. For few questions which I feel that these are the hard level problems and maybe I have to study before coming to the session, I usually try to implement it first and then I come to the session. But for the easy and medium level problems, usually I feel that directly I can go on the spot and directly work with you all, so that the information you feel also raw information will be there, and you feel that okay, she's facing a trouble, she's also getting an error, she's also getting a syntax error, and you don't feel ki I don't want to make you feel like I am the superb awesome one who has having entire knowledge in the world, and you are someone who don't have any idea. In one time go running click button, I will be able to run the code. It's an illusion again if I just give you that kind of a persona. I want to give you a genuine persona where I can showcase you that okay, I also can make a mistake, I also can have an error, I can also have some syntax error also, so that things happen for everyone, so that you will be able to get an idea that okay, if I'm also getting an error, how can I resolve that, how can I fix that. And with that intuition, I usually try and prefer ki if the code belongs to easy and moderate level, I won't do it prior. I will do it with you all. So that genuine reaction, genuine, thought will come up. Now, in that part per se, sometimes it might happen ki on the spot in the class, I might not able to get a fully optimized approach. So you can just let me know, Ki, Priya, we can do something like this as well. It is coming in my head, and definitely I'll give a thought, and accordingly we will see. Sometimes might be I have skipped something because there are multiple approaches for a given problem. And as I always say, don't limit your journey with respect to what your mentor knows. Same thing I usually say for all the batches. I conducted ML batch also, because the kind of domain I am teaching to you guys, whether it be a DSA, whether it be data science, AI, ML, these kind of things are should not be restricted to any of the mentor, because you will find learning from every resource. And genuinely speaking, I really want you guys to explore on your own also, apart from the sessions which I'm providing. That's why I always say ki practice hard research on ChatGPT platform, MIT lectures I have shared with you, because I don't want to limit your knowledge with respect to what knowledge I have. Maybe you have more than that and you can share with me. And that's how I am also learning, right? So that's the core idea. But for now, I feel that it's not feasible. You can think over it, and if you feel that no, it is feasible, you can definitely let me know. We'll have a great discussion over that point. So that's the another question that we have covered up and we want to cover up. Shall we move to the next question now,
Yes.
if you guys
About
allow
the
me?
hashing,
Uh-huh.
yes, in the recorded, the hashing code is there. I have just doubt in that code. Some actually I haven't done it. I just have a small doubt in that code.
Yes, please ask. Do you have a code with you?
Uh, it is the does the simple hashing code in the recorded session. Uh,
Okay. Uh,
Actually, I was
if you can copy paste that code in the chat, would be just like the way Rahul has done prior. That would be like, I don't have that files available for now with me. I have to
okay.
fetch from my hard disk.
Okay, I will check it, and at the end of the session, I will check it, and I will paste it in the chat.
Okay, in the meanwhile, you can check it, and let's move to the next problem. I think this is what we have done. Let me just save this problem also in my editor. Okay, let's go to the next problem. And the problem is about majority element that we're supposed to discuss, right? Majority element. I told you, right? We will discuss in this session. So I think we can discuss this as a last problem. Maybe in the upcoming session, we will discuss further problems. Majority element part 2 I have given as a today's assignment. Again, the similar kind of pattern you have to follow to solve this problem, which we will discuss today. Okay? Okay, let's move ahead to this problem of majority element, and let's clear the screen part. Can you see? Given an array nums of size n, return the majority element. The definition of majority element they are saying is the element which appears more than n by 2 times. Okay? You may assume that majority element always exists in an array. For example, we have the nums array. So what we want is a majority element. And they have given a definition of majority element. Any element which appears more than n by 2 times. Which appears more than n by 2 times. Are they talking about a lower bound of the same? Let me recheck. Lower bound only they are talking about. So if any element appears more than this time, so they're calling it as a majority element. For example, if let's say they're taking a number or list as, let's say this bigger one, so that we can understand it in a better manner. So we have a list available, right? Where we have elements like 2, 2, then we have 3 ones, then we have 2, then we have 2. 0, 1, 2, 3, 4, 5, 6. So here we will be having 7 number of elements, right? Now here what they're saying is 7 by 2. 7 by 2 is nothing but 3. So any element which is more than 3 times will be called as a majority element. For example, here you can see 2 is appearing 4 number of times. So I will call it as a majority element. What is the approach coming in your head in this question? Any thoughts for the same?
So we can count the number of elements. We can
Correct.
count the length of the array and then n by 2 like that.
Correct. So basically, if I have to use a hash table, can I use in this question also? Think over it. With the help of
Yes,
hashing
we can
specific data
use.
structure, we can directly use. Always remember, wherever there is a talk about frequency of a given data, count of a given data, majority element, minority element, you can always go for, at least if you don't understand the brute optimized solution, go for these kind of hashing based solutions, because they're pretty much easier to get an intuitive idea behind the same. So you can see that what we can do, we can create a key and a value pair for the same as a brute force approach, where I will be having unique entities again, 2 and 1. The count of those values will become my value. 2 is available 4 times, 1 is available 3 times. And now what I will check is any entity which is having a value, count value more than 7 by 2, means more than 3. I will take that corresponding key and display and or maybe return it, print it. Will that be a fine approach for everyone?
Yes.
Just now we have done the similar question, right?
Can you tell me what do you mean by lower bound?
What do you mean by?
Lower bound.
Lower bound meaning, for example, 7 by 2 is 3.5. So lower value of 3.5 is 3. Okay. Upper bound means 4. Lower bound means 3. So when you're having a decimal value, you will have to reach to lower value of 3.5, which is 3, closer value. So is that approach is fine? Do you think this approach will work in all test cases?
Yes.
Yes.
Correct? If I'll ask you again this question, what is the time and space complexity of this approach? Time
I guess big O of n.
and space. Can I say both of them belongs to big O of n?
Yes.
Now, again, if you will see this question, it's kind of a duplicate number question. But what they want is, again, could you solve the problem in linear time? Yes, we have solved that via hash table. But again, they want a constant space. I think if you run with a hash table, again, the code will run perfectly fine, just like the way it ran in a duplicate number case. But the question is, definitely interview will ask you, can you optimize it further? Maybe constant space. Can we make it this question? Gaurav is saying use nums.sort. No. In that case, if you're using nums.sort, internally the merge sort algorithm will run, which is having a n-log n time complexity, and that will not be your linear time complexity task. So you are going for a, you can say, higher complexity solution, which is not acceptable at all. This is much better than that one.
Ma'am, I guess we can assign two variables. One is the element name, and the second one is the count of the elements. And we have to just store the maximum uh, number of elements. That is basically, if 2 is the maximum, then we have to store the 2 in the first variable and the count in the second variable.
Yes, correct. So similar kind of what he has said is what Boyer-Murray's voting algorithm says. So we will discuss that now. So this is famous by the name of this algorithm which we are covering up. Again, this is now if you will ask me, Priya, this approach, I'm not able to get when I saw this question for the first time. It's okay. I think now hash table approach you will be able to get very instantly, because few minutes back we were solving this category of questions. But this is something which is new for many people. So take it wholeheartedly, what I'm trying to convey over here. Try to, understand the approach, how it works internally. And then I'll give you a similar category of a problem today, okay, as a task. You have to apply the similar approach of this optimized approach, which we are discussing today in that specific question. Okay, that's how you will learn the things. So the algorithm is Boyer-Murray voting algorithm. So what this algorithm says, try to understand. It says that, okay, you will be having this kind of an array, that's fine, which is 2, 2, 1, 1, 1, 2, and 2. So here we will be having index number 0, 1, 2, 3, 4, 5, 6. So here we will be having 7 number of elements available. Okay, perfect. This algorithm says that why not to curate a 2 variables. One is the count variable, which is initially equal to 0. Another one is the candidate variable, which is taking care of the highest majority element. For now, it is equal to none because we don't have any element. Now we start our journey. We will iterate one for loop and explore all the elements available in nums. We will do one thing. Whenever the count value is 0, in that case, whatever be the current number I have, I will make that as a majority element, which is, I will make this as a candidate only. And now what I will do is, in every iteration, I will increment the value of count. If my number, I will increment the value of count by 1 if my number and candidate both are same. Then I will increase the value of a count. Otherwise, I will decrease it by -1. And finally, I will return the candidate itself. That is the kind of a looping which we are doing. So let's try to understand what is happening over here. Initially, we are starting our journey. My num value is equal to 2. Count value is equal to 0. So because my count is 0, candidate value will be 2 itself, num value. I will say that, okay, this is the majority element for now. It will move ahead. Next value is 2. Num value will be again 2. Okay. Before that, it will try to go to the count position. It will check, is my number and candidate is same? Increment the count value to 1. It indicates that count is appearing for the one time. Again, I am repeating what I have done. Again, I am repeating what I have done. So initially, our count value is 0. Candidate value is none. Number is initially 2 because we're starting our journey from I equal to 0. Now, because the count value is 0, it will place the very first number 2 as the candidate. It indicates that, okay, this is the only majority element that we have. Now it will check, is my number and candidate both are same? If they both are same, it will increment the count value by 1. So it indicates candidate is appearing 1 time. It will move ahead. Again, number value is 2. Now, because number value is equal to candidate, count value will be increased by 1. So it means count is for now 2. Again, it will go ahead. It will be 1. It will be 1. Now, in this case, my num value is not 2. It will be 1. It will check, is my count value is equal to 0? No. So what it will do? It will go outside this specific if condition, right? So this is inside the if condition. So if the count is 0, then only update the candidate value, because it will indicate that you are reaching to a maximum majority element. It is not equal to 0. So in that case, what you have to do? Count value, agar num or candidate equal nahi hai, if they both are not same, which is happening in this case, num is 1, candidate is 2, they both are not same. So what we're supposed to do? Decrement the value of count by -1. So I'll decrement that. I'll again run further. Num is again 1. Again, they both are not same. Count is not equal to 0. So I'll decrement the count value to 0. Again, it will move ahead. Num is again 1. Candidate is 2. Count is 0 in this case. And when the count is 0, what you're supposed to do? You have to update the candidate value to the num value, which is 1. So now my candidate will be updated to 1. And now because num and candidate both are same, count will be incremented to 1. It will move ahead. It will be 2. Now my num will be 2. But my count is not 0. So I will decrement the count value to 0. Again, it will move ahead. Now what will happen? It is 2. My num value is 2. Count is 0. So at that point of time, it will update the candidate value to 2. And finally, it will return the whatever be the value we have in the candidate, which is 2. So it is printing me the answer as 2, which is the final result. So if you will observe here, it will be a duplicate element only. 2 is a duplicate element. That's what we will get as an answer.
What if we have 1 at the last, but 1 is not the majority element in an array?
What if you have 1 after 2?
Yeah,
Like,
we
this
have
is what you are saying?
1. Yes, ma'am. But,
That will not be possible.
Let's suppose that the 5 is the 6, and the 5th element is not 2, it is 1.
Let's consider
And
that scenario also.
no, ma'am. Basically, the 7th element would be 1, and the 5th element is not 1.
So let me do one thing. Let me try to take your test case below, and let's try to edit that with the whatever value you are saying.
Basically, I mean to say that if the majority element is at the end,
It will
then
work.
only
Whatever
if-
case it will be. It will work. See, tell me what you want to do. 2, 2. After that, I have 1, 1, 1. Batao, where you want to place more 1? 0, 1, 2, 3, 4.
And let's
Tell me.
place 1 in the middle. Basically, we have to remove the 5th element as well.
Okay.
Yes.
That's it. Same
Yes.
thing you want to do? Now let's try to
Yes.
see whether we will be able to get 1 over in this iteration or not. So he has changed from 2 to 1. And let's try to apply the same logic. Okay. Initially, our count value is 0 and candidate value is, tell me. Now you guys tell me. None. None. It is nothing. We have not
Okay.
edited anything.
Okay.
Now, our num value, we are starting a for loop. So what will be the num
So
value?
it would be
2.
2. So it will check, is my count value is equal to 0? Yes.
Yes.
So what will
Yes.
happen in that case? It will update the candidate value with num. So candidate will become 2. Now it will check, is my num and candidate both are same? If they
Yes.
both are same,
Yes.
increment the count by +1. If they are not same, decrement. If they are same, increment. We will move ahead. Num value 2. Again,
Yes.
what it will do? Because num and candidate both are same, increment. It will become 2. It will move ahead. Num is now 1. They both are not same. Num is 1, candidate is 2. So what will happen? It will decrement the count value. It will move ahead. Num value is 1 again, candidate value is 2. They both are not same. It will decrement. It will decrement till 0. Now, again, further it will move. Num value is 1, candidate value is 2. It will not same. And even the count value is also 0. So we cannot further decrement it to -1. So when the count value is 0, what we're supposed to do? We have to update the candidate value to the num value, which is 1. And now we have to check again. Is my num and candidate both are same?
Yes,
Is my num and candidate both are same? So I will increment it +1. It will run again. What will happen? Because now num and candidate both are same, it will run 2. It will go further. Now num is 2. Candidate is 1. They both are not same. So what will happen? It will decrement it. Loop is running fine, done. What is the value we left at the end? Candidate value. It is 1. So this is the answer. So what value we are left at the end is the answer. So 1 is the answer. So yeah, that's true. 1 is repeating 4
So
times.
basically, I have ignored that if the count will be 0, then we
That's
have to
the main
again
logic.
choose a candidate.
So this Boyer and Murray, they both are the researchers who published this algorithm, who developed this algorithm. And the beauty about this algorithm is, if you will see internally, if you will see the maths behind that now very carefully or very keenfully, that how this algorithm logic is working fine for all the test cases. See, what is happening is, we're not using any extra space. We are not using any extra data structure. Just 2 variables game is there. And at every point of time, we are saying that as soon as the num and candidate both are same, increment by +1, +1, +1. When they are not equal, decrement by -1, -1, -1 till count value reaches to 0. When it is reaches to 0, and again you're getting a different value, it means somehow num value is repeating multiple times that same value. So candidate should be the 1, which is the num, because they're a majority element. So that is where we are updating the candidate value. And same thing we will keep on repeating. So major thing is this specific clause. At any point of time, if you're reaching to a situation where your count is again going back to 0, that is where update the majority element, because there is a need to update, because that many times it is repeating. Otherwise, do this task. So this task we have to do at every point of time, at every iteration. This is if condition. This will run only if this will become true. This will run only if this will become true. This clause will run every time. Every time it will check if this both are same, incremented. Both are different, decremented. Decrement till the count value will become 0. As soon as count value becomes 0 and you still get the same majority element in num value, update the candidate and then do the same task again and again. Finally, at the last, whatever be the candidate you are left with, that will be your majority element. So think over it and then ask me the question if you have. Then I'll implement the same code.
In that question, the last line, you may assume that a majority element always exists in the array. So
Yes.
this means that we don't have 2 majority elements. For example, 4, 2
No.
and 4.
No.
So this is not in the question.
Yes.
Just one small dot is there. Can you please go to the
Yes, please tell.
yes, in the first example, no? First example, yes. Just I just can you please explain from the fourth index, just for once?
Fourth index. So I'm not sure what is the count value in that place. Let's repeat it again. That would be a better idea if you have any confusion. See this very carefully. I'm again repeating it. This is the example that we have. So we have 2, we have 2, we have 1, we have 1, we have 1, we have 2, we have 2. Indexes are 0, 1, 2, 3, 4, 5, 6. So we have 7 number of elements. Okay? Initially, the count value is 0. The candidate value is none. Right? Count is 0, candidate is none. Now we are starting our loop. Num value is initially 2. Because the count is 0, my candidate will be equal to num itself. Now it will check, is my num and candidate both are same? Increment the count. I'll increment it. Now it will go to the next num, which is again 2. They both are same, it will increment the count. I'll again move ahead. Now my num is 1. They both are different, I'll decrement the count. I'll again run. They are both are different, I'll decrement the count. I'll again run. Now at this position, when I am having a num value as 1 and they both are same, both are different, my count value is also equal to 0. I cannot decrement it further. I have mentioned a condition, if the count is 0, in that case, update the candidate value to num. So now I'll update the candidate value with num, which is 1. Is this fine, Mayur? This
Yeah,
part you're
sure.
talking about?
Sure. Okay.
Now I'll move ahead. Now they both are same, right? I'll update the candidate value
Count.
and count value will get 1, right? Now again, count is 2. Now, sorry, num is 2. So num is 2, they both are different. I'll update the count value to 0. Now again, I'll move ahead, 2. Now what will happen? My count value is 0. So I'll update the candidate value to 2. And then I'll decrement the count value to 1 because num and candidate both are same. So now at the end of the iteration, what is the final value you're left within the candidate? It is 2. So we are returning that. That is how the flow will go. Again, listen, think very carefully. And if you want, or anyone want me to repeat again, I'll repeat. See this very, very carefully. Or maybe after the session, please try to dry run this part. I think you will get it. Maybe 2-3 iterations you can do. You can take your own manual customized list and try to apply this same problem, same approach, same code, and definitely you will be able to get always majority element.
So, ma'am, in the
It
question,
is order of n, isn't it?
in the two,
One student at a time. Mayur, yes, please ask.
No, actually, I'm just thinking that time complexity is order of n, isn't it? We're traversing.
Yes, time complexity will be order of n
Space
because we're
complexity.
traversing the entire list. Space will be optimized. It will be constant.
Sure.
so ma'am, in the two of the examples in the LeetCode, so we have only two distinct type of elements. For example, in this question, there is only 2. The values are 2 and 1. There is 3 or 2. So, is it the case, or we can have multiple elements? For example,
We can have
3,
multiple.
3, 2, 2.
You can try for multiple entries also. It's by default,
Because
they
I
have
was
mentioned like
thinking
this.
about O log n uh, basically for 2 elements, if there are 2 elements. So we can
No.
do it
There
in a
can be
complex
any
way.
number of elements and there can be any variety of elements as well. It's just that I think if that is the case, they will signify us. They have not tell us. So it means we can assume any of the entries will be there. It's not that always 2 unique elements will be there. And we just have to focus on this condition that any element appearing more than n by 2 times, we need to print that. Okay.
So if there were 2 elements, I was thinking for that case that we can sort the element as Gaurav has also suggested in the comment, and then we can use the binary search to find the part of the middle element, and then we can calculate the length from that to the end of the array and subtract it from the total length of the array to get the basically length of each part. So can we further do this in 3 to 4 if there are multiple elements in the array?
First of all, the kind of approach which you are telling, it's not efficient one. It's a really huge time complexity task. See, whenever you guys are thinking about sorting, it's not something which is a easier task internally. It requires a huge time complexity. The best possible sorting algorithm we have discussed is merge sort. And that too requires n log n complexity, right? So on top of that, you are doing multiple operations. So they have clearly mentioned
Yes, got it.
about linear task. So we have to optimize it. This approach is far, like hashing approach is far better than this approach, which you're talking about, right? So we have to think, it usually feels that we just have to apply dot sort function and things will be easier, but you have to think internally when you're applying dot sort function, actual merge sort will work. It will take a complexity of
Yes,
n log n.
I forgot that it was not log n, it was n log n. That's all.
Correct. Okay. Perfect. So now let me try to apply the code over here. So what we have done is we have taken a candidate, which is equals to none. We have taken a count, which is equals to 0. Now what we're supposed to do? We're supposed to apply one for loop in the num's value. The very first thing is we need to make a check. If the count value is equal to 0, we need to update the candidate as none. Right? Right? Now, what I can do, I can just make an increment with a +1 if the candidate and num both are same. Else I'll make a count value as -1. Simple. So it will just keep on iterating. Beat any if condition, whether it's true or false. In the for loop, it will either update the value of +1 if there is a match, otherwise -1. When we move out of the for loop, it means we are finished with the iteration completely of the list. We can return a candidate. And if you will try to run this code and try to submit this, you will be able to get the correct solution. In this case, because we're just running a single for loop, so first of all, this algorithm is called as Boyer-Murray voting algorithm. And if you will see the time complexity of this approach, it will be nothing but is equals to big O of n. The beauty about this algorithm is time, though we have already figured out on the previous illustration also, the space part. So we will be easily, efficiently able to handle the space part in this question with the space complexity as big O of 1. So that's the main idea. Ask me the question if you have. It's a very simple algorithm, but for those people who are learning for the very first time, might find it confusing. Once you, at your end, try to run the multiple test cases after the class, you will be able to get a clear-cut idea how this is working.
Just a small thing I have to ask.
Yeah.
If they like in the interview, if they change the pattern of this question, that you find the list is very long list, and you find how many majority elements are there, and you return. Then we have to use. Then there will be space complexity, isn't it? We have to store the majority elements in some extra list. Like if they ask me that long list is there, and I have to there obviously majority means there will be duplicate many elements will be occurring many times. There will not single element. So then space complexity will be there, isn't it? Because I have to store them. Or
maybe first of all, it really depends on what is the meaning of majority element they are saying. There is a one problem which today I have given you as an assignment that we will discuss later on. First thing, you have to always give a thought today, whatever algorithm we have learned, can we apply the same algorithm to implement this by doing some manipulations? For example, here you can see in this second version of problem which I have given today, please give a thought over this when you come to the upcoming session. Given an integer array of size n, they are saying find an element which appear more than n by 3 times. So this is also majority element, but they're focusing on n by 3 times. They can convert to n by 4, n by 5, n by 6, depending upon that. So we can apply the today's algorithm approach also. See, taking a space, storing it somewhere, that is always one approach which you can do. It's a generalized one. You can find majority element of that. But what I'm saying is, we can also solve the same problem in a constant task by applying a Boyer-Murray voting algorithm. So today you have to think over it, that with the help of similar approach which we have discussed today, how can we make it generalized to for n by 3 question, n by 4 question. And once you get the solution of this, you will be able to get the answer of what you have asked today. Is it fine, Mayur?
yes,
So work on it, and then maybe
Yes,
we'll
sure.
discuss the same question.
I
Okay?
have shared the doubt in the chat.
Yeah, I'm just looking into that.
Hashing doubt means actually
Anyone who wants to leave the session now, they can leave. We'll not discuss further questions. I think it's too late. So maybe we'll discuss further in the upcoming sessions. One thing which you have to make sure, 3 problems I have given, power of 3, majority element part 2, remove nth node from the end of the list. I have highlighted it to a different color, assignment week 5. This week you have to, work for these 4 problems, even this add 2 numbers also. Please try to work for it. Today I thought I'll discuss that as well, but I didn't get the time. So I'm giving as an assignment only. Maybe in the upcoming session, in any of these 4 problems, you are facing any trouble, you can just let me know. We'll discuss that problem first, and then maybe I'll move ahead to the next upcoming problems. Uh, we
Can
might
we
be
have
having a upcoming session on, I'll try to conduct maybe on Friday or on Sunday. I'll again inform you in the Telegram group and will send you a mail as well. But you have 3-4 days left. So please try to finish the pending recordings of this week, plus try to solve these assignment questions which I have given. Okay.
Can we have a separate session for linked list?
Yes, in the upcoming session, we'll discuss the questions of linked list. Add 2 numbers is a question of a linked list. Remove nth node. So we'll start from a basic part, whatever we have discussed in the recordings. So the upcoming session, we'll discuss about linked list part, stack part, and then maybe if time permits, we'll discuss tree. Otherwise, in the next session, we'll discuss about trees. First focus will be on linked list and stack and queue questions.
Like in the last session, no, we discussed about in-depth backtracking.
Uh-huh.
Yes,
Yes.
there just one part of the endpoint coding I have taught, but we can discuss this in the next session also.
Okay.
And you mentioned that you will give an assignment related to backtracking also for our practice purpose in the last session.
Assignment part per se, I was talking about that task which I have given you, if you remember, and the Sudoku solver task. I told you to solve these 2 problems firstly. After that, if you want, I can provide more problems on backtracking which you can solve. But usually for now, in the course curriculum, I don't want you guys to, focus more on this part as of now. After the course will get over, I will provide you few more question list in which I will provided you more practice problems for backtracking, because the scene is, in the technical rounds, there are very few rounds in which this kind of questions will be asked. So at least, first of all, I want you guys to be prepared for 95% of interviews. And then I'll give you few more questions with respect to backtracking also and segment trees also, which maybe once the session will get over, you can practice at your end for the advanced level problems. Okay. So for now, at least whatever be the flow of curriculum of questions I'm giving, focus on that part. As of now, I'm not giving more questions on backtracking. Once our course will be over, then I'll provide you more problems on backtracking as well. Then you can focus on. Okay?
Sure. Okay.
Because there are so many things. You have to watch the recorded sessions also. You have to attempt the problems which I'm giving, and I'm giving a task also in the classes. You have to attempt that as well. So I don't want to confuse you to give overwhelming things in one go. So just focus on whatever things are there going on. And then maybe at the end, there will be few list of problems I will provide to everyone in the same sheet, which you're supposed to do once the session will get over completely. Because at that point of time, you will be in a situation ki theek hai, 95% companies, so I can easily able to crack. Now I have to prepare for just 5% companies. So in that situation, you can practice more. Sometimes what happened is, on the race of doing advanced things, people usually not able to get a consistency and expertise over the easy and intermediate things. Take the expertise over that topics first, and then basic idea you already have about backtracking. You know how can we approach, how can we solve the question. You just need practice to solve more questions that you can get maybe later on. Okay, that's the idea. Yes, please ask the question in this part. I have copied the problem.
Yes, yes. Just the summation. Only please explain the summation part. Rest things, sorry.
This one.
Yes, summation equal to 0 and only the summation part.
So basically, a few minutes back, I was talking about, right? Mayank, I think, has asked the question that how the character part is doing a division model operation. So that's the example of this. So what is happening over here? This odd function of character. So if do you know what it usually does? The odd function.
It converts into recipe.
Yes.
The convert
Basically, this, if you can just implement this function, I'm not implementing it for now. Maybe you can take a character of A and you can just check it out. What is the value of odd of A character? Okay? It will give you the sky value. So there is a mapping going over here. So what is happening is it will take every character step by step available in the key, do the ASCII conversion of that, and take the addition of everything. It will sum all the ASCII values that we have. M is the size of the hash table. So how this division modulo will work? For example, after adding this summation, we are getting some number like 100 modulus 10. So it will give the answer as 0. So it will store that specific character value at 0 specific number. That's the idea of how summation is working over here.
64 plus 36 is basically 100, and we can have two combinations here. For example, the first letter could be 36 and the second one could be 64, and there could be the second one. The first one could be 64 and the second one could be 36. Then it will fail, I guess, because in palindrome basically this the words
Yes.
are, the summation of the words are similar, but the place is only one.
That is where this kind of techniques come into picture. So that the problem which you're talking about is a collision problem, right? There is a collision which is happening because they will be having a similar value available in the hash table. So at that point of time, we can apply linear probing, double hashing, quadratic probing to avoid that collision, right? In linear probing, it will go to the next entry, next free entry, which is available. Similar to that, yeah.
The return summation modulo M, it will return the key of
remainder.
the hash. Yes, exactly.
It will
That's
return the remainder, which
and
is
we
the
are taking it as the key, isn't it?
Yes. Corresponding to that value will be the character which you want to store.
Ma'am, can you once again repeat that part? For example, if the two values are similar in the collision and the second value is stored into the next empty place, how we are
Yes.
accessing the same? Okay.
Apply the same hash function. What is the hash function of linear probing?
Okay, yeah, that is.
So same hash function will be applicable. It will just go, for example, let's say it will be at third index, some character will be available, and let's say it is CH, I'm not sure. And we are looking for any other character, maybe fourth or fifth position it is available. So it will again apply the same linear probing hash function and check that what is the next empty entry where it can go, and it is available over here. It will check that and it will return that. So whatever be the hash function you're applying to access the entries of any data item, it will definitely apply the same hash function to get the result.
So can we say that we are not retrieving from the storage? We are first creating the storage structure and then we are retrieving from the state?
Yes, correct. So in chaining, that's a different strategy. It is using a linked list. That is where storage is not an issue. But in linear probing and quadratic probing, that's how the structure will go, because then we are not using any external space over there. Right?
Yes.
Any other question? Sorry.
This thing actually we have to do the quadratic and double hash. Sorry, yes, quadratic and double hashing, isn't it? We have to do that.
Correct. Makes sense?
Okay, sure. Okay.